Hello, my name is Dale Segoy and I am a Senior Applications Engineer for Keithley Instruments. Welcome to the demonstration of the Model 2000 6.5 digit DMM and the Model 2010 7.5 digit DMM. Let's take a look at the Model 2000 first, right over here. Full-featured DMM, all the standard features you would expect, all the standard functions, DC volts, AC volts, DC current, AC current, 2-wire ohms, 4-wire ohms, frequency, and temperature. Okay? Very simple to use because if you need DC volts, you just press DC volts. No big deal. Standard on the Model 2000 is for communication is GPIB or IEEE 488 and RS-232. That's right, two instrument interfaces in one box. So if you happen to have a standard RS-232 port, you plug right in, or you use a standard GPIB port which requires an interface in your computer. It runs on standard commands for programmable instruments, command codes. That's known in the industry as SCPI. Another unique feature is the 34401 emulation mode. All that means is if you have another box from the Agilent, it's the Model 34401, you put it in this emulation mode and you do not have to have any programming changes. Saves you time and money. This particular box will measure temperature with thermocouples. It can measure with type J, K, and T type thermocouples. What you need to do is have in a little scanner card something like this. It's 10 channels and it has a cold junction compensation circuit on the card right here. What that means is your linearization for your thermocouples is already taken care of for you. This takes up channel 1 on this 10 channel card. Let's take a look at that. I'm going to go to the display, put it in temperature right here. We'll set up temperature. Very easy to do. Shift, temperature. We want the units in degrees C. Well, you have your choice from degrees C, K, or F. We'll go with C, hit enter. The different types of thermocouples. Notice there's type J, K, T. We happen to have a type K hooked up. Enter. The junction simulated. That means if you're going to simulate what you think the cold reference is, but in this case we know it's on channel 1, so we'll select channel 1. All set. One other thing, the front and rear panel terminal must be set to the back for it to go through the scanner card, so we'll just push it in. It's all set for the back. All we need to do is grab a hold of channel 1. Let's just see. If I were to close channel 1, that's the reference temperature on channel 1. It's at 25C, which is inside of the box. If we were to just switch over to channel 2, which I have a type K thermocouple on, there is the temperature. Ah, don't believe me, eh? Let's take a look. Here's the thermocouple. I'll grab a hold of it. Oh, it goes way up. Look at that. I'll let go, and it starts to come down. So that's proof that it really is working. And it'll come back and come down to room temperature. Very handy with thermocouples on the Model 2000. Another instance on the 2000 is the tighter accuracy. The tighter accuracy, I mean, is on DC volts, ohms, and so on. It is about roughly 30% more accurate than the Model 2100 and therefore puts it in another class. So if you think of it, the 2100 is here, the 2000 is the next level up with its certain functions and features. But it's the tighter accuracy on DC volts and resistance that makes it in the tier that it is in. That's the Model 2000. Very handy 6.5 digit meter. Let's move on to the Model 2010. The 2010 is a 7.5 digit DMM. Happen to have one right over here. Set that up. The 7.5 digit multimeter 2010, like the 2000, they're very close and similar in everything except a few features. The 2010 is a 7.5 digit. It also includes GPIB and RS-232. Standard Skippy commands, SCPI, just like the 2000. It can also measure temperature, but the main difference here is it'll measure temperature with the 3 types of thermocouples, J, K, and T, but also RTDs, which are resistance temperature detectors. That gives you a far more accurate type of temperature measurement. One of the key features of a 2010 is its low noise capability. By low noise, I mean it's extremely quiet. Here is a low thermal 4-wire short from Keithley Instruments, the model 8620. We're going to push it onto the front panel terminals. Notice the display goes almost to 0 immediately. Okay, so let us select a rate of slow, filter on, and we're going to do a little test right now. Won't take too long. I'm going to store 100 readings into the box, and while it's storing, you'll see the little asterisk come up saying the buffer is activating. Now it's going to take a few seconds for it to fill, and what we'll do is recall the buffer statistics, the math functions. We will see the standard deviation, the min and the max, all stored in the buffer. I wanted to show that so you can actually see how quiet this box really is compared to a standard 6.5, where a 7.5 really comes up. Okay, look, the asterisk has disappeared. That means it's ready. What we're going to do is press the recall button. It says reading number 1. Well, let's take a look at that. Okay, that's very low, but what I'm really concerned in is the standard deviation. So if I go below that, here it shows me standard deviation. Look at that number, 71.326556 nanovolts on that thing. This is quiet. It is almost coming to the realm of a nanovoltmeter. This is a low noise multimeter. There's no doubt about it from this proof. You could see the rest of these buffer statistics, average, min, and max. But the one that was really important was the standard deviation of 71 nanovolts. Very, very tight. It also has a 10-channel scanner on it, like the Model 2000. They both fit in the same. We could do the same type of demonstration there, but just suffice to know that it is available. Since it is a low noise box, one of the things we can do is measure 4-wire ohms very, very accurately, because when you're measuring low resistance, you're really measuring low voltage. Let's hook up something to show you that. Now I'm going to show you right here. I'm going to take that off. I'm going to put on a set of test leads known as Kelvin test leads. These are our high-end Kelvin test leads into the instrument. And I will select 4-wire ohms, but in a minute I want to show you what I'm going to measure. This is a standard paper clip. I unraveled it and I have the 4 wires on each end, the low and the high. A standard paper clip is normally about 20 milliohms. Let's take a look and see. Let's look at the front panel. I will select 4-wire ohms. Okay, it's about 22 milliohms. How can I know if that's real? If I were to move the clips, halfway in we should see about 10. Watch that. About 10.8. So I know this is operating properly. Okay, so this is really good for this. One other feature that it has for measuring low resistance is offset compensation. Offset compensation means we are going to take two measurements, one with the current on and one with the current off. I'm going to put that down for a second so I can work this. And what it does here, I'll press shift, offset comp, O comp off, on, enter. Okay, now you're seeing the 20 milliohms with the little O on the front panel saying it's an offset compensation. What did that do? Let's take a look. I'm going to grab a hold of the this 20 milliohm resistance and look at the display. I'm holding it, but the display doesn't seem to be changing much. Can you see that? Okay, let's take it off of offset compensation, and you will see that that makes a big difference. Okay, now it's bouncing around a little higher. I'm going to hold on to the lead again. Now watch the display. I'm heating up the lead. Whoa, it's going up higher and higher and higher. That's the thermal effects when measuring low resistance. Thermal effects are thermal EMFs. That's the biggest source of error when measuring low voltage. When you're measuring low voltage, it's really measuring low resistance. So the model 2010 has this offset compensation feature that is very good for low resistance measurements. It also has something called dry circuit. Dry circuit just limits the output voltage to less than 20 millivolts. 20 millivolts is a standard that says it won't puncture oxide coatings to get a less than normal resistance measurement under real applications. And those are the features of a Model 2010 and the Model 2000. They both have their individuals, 6.5, 7.5, and different features for each. All in all, great instruments from Keithley Instruments. I would like to thank you for viewing this online demo of the Model 2010 and 2000 multimeters. Please visit the Keithley website for more information.